Hi, and welcome to AIoT Hub. I'm Paul Wheels. I've been on a bit of a hiatus for a little while, and my friend John has been driving the car for me. Thanks, John. How are you doing?
All right, yeah, not bad. Just been cycling past your house apparently, but I didn't realise you were there. Been
Yeah,
cycling Northumberland coast, 170 kilometres in 2 days, which is I had some great weather on the way, so yeah, really nice.
yeah. I'm a little bit gutted that we didn't get to catch up whilst you were in my hood, so to speak. Literally 10 minutes down the road from me as you set off on that journey. But
Yes.
I'm glad you got to experience our coastline and in warm weather as well, which doesn't happen very often this year. Or without rain either. We've had an awful lot of rain up here this year. But hey, John? What projects and what fun stuff have you been doing over the past few weeks?
Bit of IoT stuff, bit of front end stuff, lots of web development, sorting out some speakers for AIoT Hub. So we've got Nico Stellis coming in January. We've got a special event mid-January, how to manage a farm of robots using Azure IoT and digital twins, which should be a really interesting talk. And then we've got Omar Rana from the Edge AI Hub, our sponsors, doing a talk. As yet, they've not disclosed on what subject. So lots of interesting stuff to come this year and next year, but no meetup in December as usual.
Yeah, we'll take the little bit of a break for Christmas. And if you hear any fireworks, obviously it's November 5th. So there's an awful lot of them going out from my new place at the moment. We also have a live in-person event in London. Is it February we're going to be doing that with the university? And we're also going to attempt to live stream our session of that. There'll be a number of sessions through the day, as I understand it. So more information shared about that around January time.
Yeah.
Today we have, no, we don't have Marius. We have Marcin joining us from Bite Lake. Hi, Marcin.
Hello, hey, how are you?
Very good.
Thank you for inviting me.
Oh, well, we've actually been organising this for a couple of months, if I remember rightly, and so really excited about having this talk. We're going to have you sharing about getting ready to dive into the future of AI and smart factories and energy utilities, uncovering how edge AI solutions are revolutionizing industries, boosting efficiency and enhancing reliability and driving innovation like never before. Would you like to give us just a little bit of insight about Bite Lake and how that got started?
Yeah, so we started the company back in 2016 together with my friend Mariusz. We're trying to figure out how we can bring innovations to the world of industries, different industries. So we started talking with our friends, family friends, right, as usual. And it turned out that some of our best friends and my brother studied AI back in the days when it was called machine learning, and were doing really nice things in optimizing the algorithm. So we figured out why not trying covering or bridging the gap between the academia and the world of business and building together a couple of solutions that could help boost operations, improve production across industries, and that's how it all started. And gradually over the years, we started transforming more into a product company. So we started with doing everything for everyone requesting any AI. And then over the years, we narrowed it down to a few of our products, and I'll talk about the case studies later.
Excellent. And how long's Bite Lake been around?
Ever since 2016.
2016. And what's been the biggest challenge for you over that period?
I think I would say the first challenge, a couple of challenges we faced were along the lines trying to convey the message of AI to industries, right? So AI at that time was mainly in science fiction stories, right? Mm-hmm. And then we had to explain and transform or translate actually the technology into use cases that make sense. So it was, the learning curve was along the way. Like we had to, understand the industrial language, we had to understand technology, and then help end users translate that into use cases. So that would be challenge number one. But then, of course, everything that comes down to building the product. So building the strategy, roadmap, and again, trying to pinpoint the pains across different industries. So, but it's also fun because we love talking to people. We love exploring new areas, and pains lays in new areas. So that's where, always put our foot.
What's your favorite project that you've worked on through that period?
I would say the energy sector. That's probably the most eye-opening project. I'll talk a little bit later on, but just a sneak peek. AI is so different from other IT projects. If like that, AI is always about working across different domains. So you need to work with production people, IT people, domain experts who know the product, who know the production line, and so on. But also, my favorite project in the energy sector is because that's one of those projects where you not only deliver the solution to the customer, but you also help customers, fix their own processes along the way. And I will explain how we did that. But that's most I would say rewarding part of the project.
Excellent. I think that leads very nicely onto you doing your talk. So I will share your screen here, and you can fire ahead with your talk.
Absolutely. So thank you. So just a quick confirmation. Can you see my full screen right now?
Yep, all good.
Okay, very good. So thank you everyone for joining today's webinar or meetup, and thank you again for inviting me, guys, to your regular meetup. And today I will talk about AI in the context of industrial deployment. So I represent the company named ByteLake, and we have a very practical approach to AI. So I'll focus purely on case studies, and I will summarize some of the lessons learned. And I'll be available for Q&A over email, phone, if that sparks any questions. But anyway, AI in smart factories and energy utility companies, that's the main theme for our webinar. Yes?
We're just getting a full white screen.
Okay, let me reshare that again.
It looked like you were sharing your StreamYard screen rather than the presentation screen.
Slides. Okay, present. Sharing screen. And entire screen. Okay.
We've got your... You've got the wrong. Yeah, you need to flip it around to share the other one.
So let me fix that one very quick for you guys. Okay, so back to the main screen. There we go. So share screen. So right now I'm sharing the entire screen, and you should see the full screen.
Yeah, if you go to, you should have, where is it, switch. You need to switch because we're currently seeing the backstage of your slide so we can see your notes. You need to switch it so we see the actual presentation and you see that screen.
That's weird, but because I'm sharing explicitly the... Let me just... Sorry for those who joined already. We're having some technical difficulties here. So I'm sharing the entire screen, and okay, so it's called screen 2 right now. Is
there
it
we go.
better now?
Yeah, we've got it.
Okay. Okay. So, we need AI for selecting the screen, right? Anyway, that would fix the problem. But anyway, as I said, today's focus is automating production processes and reducing energy waste with AI. And I will talk about this with the words of case studies. So the key topics for today: real-time energy optimization, right? I'll talk about how we integrated AI AI into different processes, but I will specifically talk about leveraging various sources of data, like IoT data in specific, but also other data that becomes useful along the way, like weather forecasting, experts inputs, and all the, let's say, digitalized knowledge that you might have or collect along the way while you develop a production company. Then AI-powered automated quality inspection will be the next theme, and I'll explain the AI's role in analyzing products quality, but also going beyond products to monitor, and how we actually leveraged AI algorithms to monitor processes as a whole. And last but not least, predictive maintenance and energy efficiency, and I will specifically talk about our latest deployment at the energy utility company. But I will also talk more about how predictive maintenance helps deliver value in industrial settings. So let's start by, there's been a lot already said about what AI is and what it can do, and there are already stories, fairy tales about AI. So AI is presented these days as anything between something that can, destroy humanity and kiss our existence, all the way to solving any problem in the world. But for us at ByteLake, AI is just a collection of the algorithms that takes data as an input and transforms or helps transform the data into actionable insights, which we collectively call typically as an information. That's the promise, right? That AI can do. And moving forward, if you connect to these algorithms cameras, then all of a sudden AI will get eyes so that AI can see. If you connect microphones, then AI can listen to sounds and monitor quality based on the sound waves that it gets. And then naturally, if you expand microphones and cameras with any IoT sensor, like measuring pressure, temperature, or any historic data, or live input from either experts or maybe weather forecasting systems, then AI will analyze or tap on all of these sources and then transform or help you find the answer hidden in this vast amounts of data. So talking about the use cases that fall into the, let's say, three buckets that I just created: visual inspection, or computer vision, or machine vision, probably the most common use case in industrial settings. It's all about visuals. It's about finding, or analyzing images or videos and performing visual inspection of objects, products, processes, if you like, and then finding things like scratches, or reading the labels, checking the barcodes, or maybe monitoring the processes as a whole, and then counting objects, maybe checking their quality before they're shipped, and monitoring the labels along the way, and then helping you find the proper part in the video, and stuff like that, right? When you connect the microphones, as I said earlier, then you were talking about sound analytics. So then AI can enable proactive maintenance, can monitor bearings, car engines, or any moving parts, and like filters, pumps, and then based on different nuances it can find in sound, AI can assess certain qualities, or maybe count some issues, and then become a foundation for your predictive maintenance system. And then naturally, if you expand this into other sensors and all of the data that you digitalize in your company, then AI can help you answer questions like why something happens, what will likely happen, why something happened in the past. AI can find dependencies hidden in the data and help you process really fast the whole amount, like a vast amount of data that you have in your organization, and based on that, help you make better informed decisions, right? So like we all collect, or we all generate the data. Even me talking to you right now, I have my smartphone with me, and it probably records my location. It records some sort of my activity. My smartwatch, and yours too, records a lot of data, and we're broadcasting this meetup over the internet, and then some metadata is generated. So we all generate the data, and this is very similar in industrial settings where we generate the data from sensors. We collect the data by taking down the notes, or from audits, or from inspection, quality inspection, and via emails, chats, and so on. And AI gives this promise that we can process that data and turn it into information so that we can make better decisions in the future. So how it looks like when it comes to deployment of AI in industrial settings. So as you can see on the screen right now, it's that typical deployment architecture. So moving from left to right, what we can see here, on the left-hand side, you see the different or various sources of data, like data collected from production line, assembly line, from overall your infrastructure, measuring temperatures, pressure, maybe the speed, rotation speed. We can see here some. Let me see if I can use the laser pointer. We can see here different data sources from databases and so on. So all of this data can be collected on a storage server or directly sent to AI, which is here visualized as a typical edge PC, which is in the size of a CD or it's really small PC. It's industrial grade PC, and then the configuration of such a PC can be very simple. It can be like CPU like i7 from Intel, and maybe 32 gigabytes of RAM with Linux on it, and then AI can be installed directly on that PC and process that all the data that it's getting in real time and turn it into information, which you can see on the right-hand side, and it can be visualized in any sort of a dashboard. Like it can be like a like a graph showing you the percentage of how likely it is that certain part of your infrastructure will fail, when you should replace some filters or maybe schedule the maintenance work, and so on and so forth. So that's the typical deployment. And throughout the rest of this webinar or meetup, I will refer to this reference architecture as this is the like a typical deployment. Taking a deeper dive into overall infrastructure that is needed for AI, and that's probably nothing surprising for most of you. Before AI can take on any task and deliver value and actually turn data into information, it needs to be trained. So long story short, we need to collect the data, we need to clean the data, and that's actually what you guys asked at the beginning. That's actually the part which generates the best stories of any AI project. Like anytime you ask any of your customer, do you have the data? The answer always will be yes, we have the data. And sometimes they will add something like, we have data from past 10 years, from maybe 1 year, or maybe half year, whatever. Whether they have the data you need for AI and they need for their AI, it's a question how the AI model will perform. So you collect the data that you have, you clean it, and then you perform your first training. And then you always will see surprised faces that will say something, okay, we forgot to tell you, but actually the sensor that is used on machine A never worked, and we always fix that in Excel sheet, right? So these are the kind of stories you need to be ready. But anyway, once you go through this, you train your AI model, you calibrate that, and I'll talk about it later by explaining some case studies. You're done with the training. Then when you deploy AI, it's called AI inference, meaning that you execute trained model, and that's actually where the data is transformed into information, and that's the real value for the customers. So the customers, they need to understand that they need to go through the training, but the actually value where they see will be the inference. And then, of course, this loop here on the right, in the bottom right corner, is a natural loop. So, as we evolve as companies, right, we improve our process over time. We generate more and more data. We add more stuff to our products. We, enhance our production lines and so on. So do AI models. They need to evolve and they need to keep the pace. So, so that's why we need to always remember that there needs to be a loop between how our processes and our company evolves, connected with how our models should, improve over time. So we call it retraining, we call it calibration, and it's all about, feeding AI models with new data and regularly upgrading those models or retraining those models so that they can always adapt, right? Sometimes it's a loop with the expert who, punishes the AI whenever it makes a wrong decision and, gives it an award whenever it provides good feedback. Or sometimes, when the environment changes, we want to retrain our models to adapt to these changes. And so that's the overall like the process that is needed to deploy AI. One thing I wanted to mention is edge AI, and I wanted to mention that explicitly. AI can be deployed in many ways. Like it can be either deployed as a cloud service, so that every time you want to get an answer from AI, you need to send the data over the internet or any network, right, to your cloud, whether it's local cloud, hybrid cloud, or your public cloud, and then get the data back. In industrial settings, in most of the cases, what we see at ByteLake, AI is deployed in the edge AI fashion, let's call it this way, meaning that AI is deployed 100% on premises and turns or transforms the data into information on the devices where it is installed, right? So that gives you a couple of benefits. Like first of all, you're independent from third parties, right? So to say. Then the data is processed locally, and then you don't have to rely on your bandwidth or internet connection, and which is a major problem in industrial settings, right? Low bandwidth requirements, or high bandwidth requirements for AI is a typical problem. And then whenever something breaks, or we want to install AI on additional production line and so on, you just copy paste the device, right? And you just want to maybe calibrate that to different conditions, maybe slightly different lightnings, maybe different different shadow structures, stuff like that. So anyway, so that's the edge AI. So edge AI, for the sake of this webinar, let's remember that edge AI is about running trained AI, so AI models directly on the devices and processing the data locally, which also has an impact on your privacy and security, as AI can be fully deployed in your infrastructure, server infrastructure on premises. Moving forward, so how does it happen that we end up with a need of having AI? So it's a little bit different for AI comparing to other IT projects. As with AI, we need to start with the use case we need to solve. So the inspiration for any AI deployment always comes from the use case. So we want to improve the quality. We want to analyze this amount of pictures. We want to improve document processing. And then once we come to a conclusion that, okay, we need AI, we need to go through certain process, and I will not talk much on that part, but in general, once you have an idea for your ideal solution, you need to start collecting the data. So that's the stage where the interview starts. So you need to nominate people who will become responsible for delivering the data, typically production people, quality people. There needs to be a product manager or project manager for this endeavor, so that they can, give the power to the people, so that they spend some extra time on collecting the data, on cleaning the data. There will be people asking your production manager about what this type of data means. Like, for instance, if temperature is part of your predictive maintenance solution, then will it ever go beyond 200 or maybe below 50? So that's the information we need to collect as well. And then we need to clean the data. So we need to, find all the areas where, like I mentioned earlier, I forgot to tell you, by the way, that this sensor never worked. We always fix that. It's readings in an Excel sheet manually. So, AI at this stage is about not only collecting the data from your organization, but also about digitalizing the knowledge and all the experience your teams have and have gathered along the ways, and whatever makes sense to address your use case. And then once we collect the data, we do the training, and then we need to calibrate those models. Like if AI is supposed to perform the measurement of certain objects, then we need to calibrate that so that it knows the surroundings, it can get the perspective on the objects so that it understands the measurements of some objects around it. And then the last part is obviously the integration, which is not a small step. It's actually a very challenging task because it comes down to implementing the change throughout the whole organization, which is also a fun, because you need to educate people first to use your AI. Then you need to integrate that AI into existing IT systems and solutions, and then you need to work with those people to help them overcome different habits so that they really start using AI. Because if they don't use it, AI will not improve over time, and will get lost along the way. But anyway, so that's the long story short, the introduction, just to set the stage about what AI is and how it is deployed and how it's delivered to organizations of basically any kind, because I think this process that I just described will be common for most, if not all, of the organization. But let's start with so I grouped the case studies and the experiences we've gathered at ByteLake in a form of groups which gradually become more and more complex. So we'll start with the simplest group, and then we'll add some more, and we'll end up with the most complex deliveries that can collect all of the data. So let me know if Mariusz is already on the line. If not, I will continue. Probably we're having the technical difficulties there.
Yeah, he's not joined us as yet, no.
Okay, so no problem. So quality inspection is the first group of the use cases and the projects that I will cover right now. So as you can imagine, it's about products and processes. So the first one falls into the first bucket that I described at the beginning, and it's about computer vision or AI-assisted visual inspection. That's how we call it at ByteLake. And by the way, you can read more on our tech brief linked at the bottom of the screen. But anyway, as you can see, the implementation or deployment of such AI system is very similar to what I described earlier. Like on the left-hand side, we see the data source, which in that context is a camera or a set of cameras, and then the pictures from the camera are one by one sent to the edge device, which contains trained AI models which are deployed on that PC. It can be as well a virtual machine in the cloud. It really doesn't matter. It needs to be some processing unit with trained AI, and then the image is turned into information in a way, as you can see on this on the right-hand side. The goal was to find a quality issue and then mark it with the red rectangle, so that we can monitor the products which are created at the assembly line, or maybe are becoming part of the larger product. The goal of this solution is to turn the data into information as fast as possible, so that quality inspection does not slow down the whole process. It can operate in difficult environments. So typically the PCs like that are used for harsh environments like high temperature, maybe the humidity might be high, and so on. Wireless options, then the data can be transferred to the device or to AI wirelessly through Ethernet, and the infrastructure, most importantly, is typically scalable. So if you have one production line, you just need one device. If you have two production lines, you just copy the same device to different production lines, and then you typically need to calibrate that for different shades or different lights and so on and so forth. So that's the obvious, right, deployment. And by the way, this can be about quality, but it can also be about the quantity. So we've had use cases where we're supposed to count objects, read the labels, but also which is very interesting, the quality inspection can also monitor the ensure the security, or maybe ensure help you avoid certain situations where can cause damage, or maybe can cause dangerous situation. Like it can read labels from different products and make sure that you don't place products which put together can create some dangerous substance and so on, that they don't get close to each other, right? So that's where AI is also used. Another case where we deployed AI, and that's maybe not so common use case, and I'm quite sure that not so many of you have seen deployments like that. It's for the paper production monitoring. So long story short, if you look at the bottom left corner of the screen, you will see a small picture of the paper making machine, and it works in a way that the pulp, which is like a major ingredient of the paper, is poured around the headbox area on the so-called table, and it's gradually dried out, and it goes to the press section, and then that's where the paper is formed. But the natural, so it's a multi-phase process, right, creating the paper. And as the time passes and the paper dries out, a natural phenomenon occurs, which is called the wet line. So the ingredients of the paper start vibrating, and sometimes you might observe the area which is wet, but it looks like a glossy area visible on the left-hand side and on the right-hand side, which is called the wet line. And there's nothing wrong with having the wet line, but you need to just monitor that. And if it becomes too big, or maybe too small, or it gets too close to the rolling machine, the paper might break, or it also has an impact on the paper quality. So it needs to be measured, and it needs to be monitored. And typically what's done, there is a person walking around that huge paper making machine and monitoring it manually, and then just reporting if something dangerous or suspicious is noticed. But we as humans, if the process is slow, because it might take, like, I don't know, 15 minutes, maybe 2 hours before the wet line pops up, we might take a break. During the break, we might get involved in some small chat and small talk, and then when we go back, if we're not lucky enough, then the paper might be broken, and we need to clean the machine. We need to destroy the whole roll of the paper, because we cannot just glue it. No one will buy it. But anyway, the simple solution here is that we install the camera around the paper making machine, because you cannot risk that anything will drop onto the production table. And then the camera, as in the previous example, was regular taking pictures and sending these to trained AI, and then providing insights to the steering group about the detected water line or wet line, if you like. So the first information was if it's there or not, obviously, and the second one was the size of the wet line, right? And based on these two pieces of information, the steering group was able to automate some fraction of the process and add it to their AI digital journey, right? Optimizing the whole production process. And these industries typically operate on thin margins, so they cannot, let the unsuspected, downtime happen, and the cost of this, the cost of unexpected downtime in the paper industry is estimated to $200,000 and a day, right? So that's huge. And then with solutions like that, they can add another security or improve another security level to their monitoring. And like solutions like that can operate 24/7, right? 365, and then they can work efficiently, and they can provide you with. So I call this kind of solution as an advanced calculator. You can, of course, perform complex math on the paper, right? And it's good if you can do it still, right? But why doing so when you can focus on more creative stuff, and AI can offload you with some boring, tedious jobs like this one, for instance, right? So that's and by the way, people no longer want to do it. So that's that's also one of the reasons why industries decide on deploying this kind of solutions. Another one, let's jump into using mics. And so, again, the deployment architecture is very similar. So on the left-hand side, we see an array of microphones recording sound produced by car engines on the assembly line, and then the sound waves, sound samples are sent over the network to some edge computer where AI is deployed, and then again AI is about the goal of AI is to find the nuances in sound recordings so that we can pinpoint potential quality issues and find defective engines. And same story. This task was typically performed by humans standing in the center of the assembly lines, and then listening to sound generated by car engines. Very skilled and passionate people, and I was really amazed when I followed their work. They were just by listening to the sound generated by car engines at the assembly line, they were able to find out which should be removed from the assembly line and sent over for additional tests. And then they were even able to say what could be the potential reason of the quality issue in particular engines. So we worked with these people. It was really challenging to not only to record the proper sound samples, but to digitalize their experiences, right? And there were also issues that different people at different production lines had different sense of sound, and there were sometimes having different conclusions about the sounds that they heard. And AI helped them, sometimes at some point AI helped them to unify the quality process throughout the whole production plant, and most importantly, eliminate potential human errors. So in that settings, AI never let faulty engine go without further tests, and generated below 5% false alarms. So that was really good, and overall it improved the reliability of production, right? So that's but again, the process was done manually, like in the paper making monitoring, and again, the human thing, like people no longer want to do it, right? And it's extremely hard to train people for this particular job. And while you can copycat the experience, you cannot copycat the passion, right? So it's even harder to find people who are willing to stand at the production line and for 8 hours straight listen to sounds generated by different car engines and then deliver quality results by manual. So again, like AI becomes here like an additional calculator, which you can still do the job manually, but AI can become your guide, helping you transform the data, which is sound, into information, right? So that's another case, maybe not quite obvious, right? I was quite surprised when we delivered that solution to the market, as we used to work with sound data in the past, but we never thought about the use case like that. But that's very interesting. But one thing I wanted to mention here, and actually in the previous case as well, like for cases like that in industrial settings, remember that your environment will always change over time, whether it's for sound, like things like the temperature, humidity, which has some impact on the sound quality and how it is transformed. And when it comes to papermaking monitoring, it's all about the lights, because there might be windows around, there might be it might be an open area, there might be shadows, and AI needs to adapt to these changes. So solutions like that need to be automatically retrained, maybe in every week or maybe in every month. It's very process specific, but that's very important. But moving forward, right, because we only touched microphones and cameras now, to IoT data analytics and predictive maintenance, which has many phases, and I'll uncover quite a few. So what is predictive maintenance? So it turns out that there are different levels of how you want to optimize the maintenance or schedule the service in your factory. It can be either preventive maintenance, so meaning that you try to avoid at all costs all possible damages or failures or errors that might potentially happen in your factory. Very expensive approach, requiring you to replace all the components even before they are worn or maybe broken. Then on the other side of the spectrum, you would have reactive maintenance, which would be more about reacting after something happens, right? So again, maybe very upfront, it might seem that it's a very smart approach because you don't burn money whenever it's not needed. But as I showed you last time, the unexpected downtime might cost you a lot, and it's not just about fixing your machinery, but also lost opportunities, right? And slowing down the production line and the cost of people focusing on some other stuff rather than doing the job that they should. So they would rather focus on fixing. So that's reactive. And somewhere in the middle of that, the optimized approach is called the predictive maintenance. So meaning that you fix the stuff or fix the components or replace them, not after breakdown, not before, but when it's required, right? And it's optimized in a way that it's predictive maintenance is supposed to lower the risk of breakdown significantly. And but one of the cons of that would be, again, like a little bit higher fixing costs, right, rather than when you do it afterwards. But anyway, that's the optimized approach, and how it's done in the industrial settings. So it's typically about collecting all sorts of data and analyzing them collectively. It's not just about finding answers hidden in one set of data. Predictive maintenance and data insights is about, analyzing the data set or all the data produced by all of your data sources as a whole, and then trying to find the dependencies between the data, trying to find the correlation between the data, combining it into information that you need. It might be about providing you information like when something will most likely break, or maybe when you should replace certain sensors, or maybe when you should replace the camera, clean the camera, or how you should set the machinery to work in an optimal way. But also, when it comes to IoT data analytics, it also goes beyond that, because it's not just about predictive maintenance, but also about finding the optimal configuration of your machinery. How am I going to deliver maximum productivity, and how I should set my overall machinery or configure the whole supply chain so that I have all the products or sub-products that I need to create my end product, and then how I should configure my processes so that I deliver optimal results. So to sum up this part, with solutions which are collectively called cognitive services, the key features that we typically have are about visual inspection. So it's about inspecting the products, parts, components, continuous process monitoring. So that's one thing. Sound analytics. It will be interesting to see maybe in comments how many of you worked or maybe see some potential use cases for sound analytics in your environments. Data insights collects this too and adds more with IoT. Like it leads us to optimize manufacturing operations. One thing I didn't mention when it comes to data insights, it's also about the back office task optimization. So when talking about production, we typically focus on the factory floor, but remember that whatever you do at the factory floor is also closely related to many tasks that happen in the back office. So AI can also help with document processing, optimizing the processes there, like helping you do stuff faster, AI monitoring before you ship the product, then monitoring that you attached all required documents, met all the certifications, and so on. It ensures high quality standards, right? And then it can give you the real-time alerts. And moving forward, when you combine everything that I just said with IoT data analytics, and you connect the IoT sensors to not just your machinery, but also to your, let's say, distribution channels, then you can talk about optimizing your whole company. And that's an example on which I will focus most. So let's talk about the AI for the energy utilities companies for a while. So what we can see here on the screen, on the left-hand side, we see a typical smart city or smart factory setting. The goal there and let's focus on the heat distribution use case. So the goal for the smart city is to ensure that throughout winter seasons the heat is delivered to every node of the city, meaning flat or a house or a factory. In the context of a smart factory, we want to secure that our conference room get heated and so on. So typical use cases for end users. On the right-hand side, we have the energy or utilities generation, like a energy plant. And then somewhere in between, we typically have the utility company, which is responsible for distributing the energy, whether it's power or electricity or energy or heating energy to end users, meaning smart factory or smart city. And the goal for the utility company is twofold. First, they want to deliver quality service, meaning when it in the context of delivering heat, they want to deliver proper heat level to each part of the city or a factory. But they want to also optimize their costs, so they don't want to, order too high temperature or maybe too low temperature, so that they provide quality service and don't waste money and in our context energy. Another goal is to ensure that the whole infrastructure, whether it's electricity or heat infrastructure, works in an optimal way. So there will be some substations with pumps. There will be some local substations distributing, energy in districts or maybe in some select areas, and you want to make sure that they also work properly. So you want to monitor their operations and how they operate and the overall quality. And typically, this job or this kind of jobs are done by operators at the utility company, and again, like in all of the previous cases, these are people that have huge experience, and then they can steer the whole machinery in a very optimal way. But as humans, we're sometimes emotional, right? And seeing the weather forecast, which is unstable, or maybe our experience tells us something how we should react, we might either have a tendency, and again, it's a people thing, right? Some people will be more risk adverse and will stay on the safe side, so they will focus more on delivering proper quality service throughout the city, and they will order maybe too high temperature, but whereas others will be more risky and will take a risk on reducing the overall temperature of the infrastructure, and will eventually order the lower temperature, right? So we've seen cases of people doing both, and on one hand side, they might generate too much cost for the utility company, meaning they will waste a lot of energy. And in the other case, where they reduce the temperature too much and they take too much of a risk, then at some point they might this decision might have an impact on the overall reputation of the company, because they will not deliver, right? They can't deliver. They can deliver if they if they order too low temperature. But anyway, AI here is a very complex system. It consists of hundreds of AI models collaborating together, and then the way it works, it takes into account all the data from the city or from the factory, where it collects input from substations about the pressure, energy consumption, the temperature on different points, and so on. Then it also, collects the data, historic data, how typically in different situations operators performed, what decisions they made, right? And then again, AI also, connects to, in that case, it makes sense, right, to connect to weather forecasting system, so that AI can, understand what's the weather going to be like in the next few hours or so, and then based on just this data, right, plus maybe dynamic pricing of energy and so on, and based on all of this, AI gives you the input about how you can run your whole infrastructure in an optimal way. So first, it can help you set up properly the pressure on different substations. Maybe it can help you decide or suggest what temperature you should order for the next maybe 2 hours, maybe 8 hours, and then how your network or how your overall infrastructure will perform, right? And most importantly, it helps you not just run your operations smoothly, but also help you reduce the energy waste, right? Which is very important for this kind of solution. Another thing, like in systems that are complex on this level and with so many data flying around from IoT sensors, from databases, and actually all of the sources that you can imagine, all of this data becomes a source for different alerts that are generated throughout the system. And we need to remember that in real world, there's never a solution where all of parts of such complex systems are built on single software or on a single software, so single vendor, right? We have many systems working together, and that leads us to a situation where many systems generate different alerts, which are then collected at some alert center, and operators with little experience or who don't address all of the alerts might get lost in that, right? So AI again can help you prioritize the alerts and based on how you reacted to different situations and how urgent or severe certain situations or alerts might be, it can help you also prioritize the job. So that's another thing. And then of course all the other stuff like helping you better manage the schedules for your service team and so on. So that's what typically happens. So to sum up, right, this part, like the good this kind of solutions can also be applied to the energy sector, where typically these days more and more companies build their own local data centers, and sooner or later we'll end up in situations that commercial deployments of the edge servers or HPC infrastructure will start competing with with demand for electricity. So again, AI can help you prepare for that era and predict the demand. So to sum up, right, all of these parts, so key benefits of AI. So from industry leaders and from analysts, we get different numbers, but some of these you can see on the screen right now. But in general, when talking about AI, we're talking about lowering the amounts of breakdowns or unplanned downtimes. We're lowering the maintenance cost. We're increasing the productivity. And in terms of the automation, we're generally talking about, continuous monitoring, optimized operations and maintenance. So we reduce unnecessary downtimes, but we also pinpoint the failures. We automate the processes, quality inspection process, so we ensure we have consistent understanding of what quality means in our production line across the whole plant, right? And with IoT systems specifically, we as I mentioned, I repeat that we all generate the data, right? And with AI, we can make data-driven decisions, right? We can again reduce the downtime, but what's more important with analyzing the IoT data specifically, we give the input for the maintenance teams how they should schedule their work, their jobs, and where they should go first instead of just going across the factory station by station. If you want to learn more, just visit our blog or contact us directly if you have any questions. So that's all I prepared. We're almost on time, so that's all for what I prepared for today, and hope it will inspire you to explore AI further in industrial settings. And if you have any questions, just you can address this now.
We've got a few questions. So I'll let me jump onto them. So hold on. I'm getting there slowly. Nick Young, does Byte Lake have their own training compute, or do you use cloud training based on the project?
So for most of the projects, we leverage our own compute power. So we have servers, but we also work with partners like, for instance, Lenovo, with whom we deliver the training AI training capabilities in terms of hardware. We hardly ever leverage virtual machines because for most of the time we need to transfer a lot of data for the training and we need to do it back and forth. So that's not optimal for us. But yeah, we never say no. We have some products which we trained in cloud and deployed in cloud. So
okay.
that's
Thomas says, very interesting. Thank you very much. Does Byte Lake have a common neural model or components, sub-neural nets that handle weather, etc.?
Yeah. So when it comes to weather, depending on, because that's interesting because we handle weather in different cases differently. Like in the context of the case studies which I described, the weather is just a data source for us. And yes, we do have components which work with online weather forecasting services, and then they collect the data from that. But we also do CFD, a computational dynamic, where some of our models are used for weather forecasting. But anyway, that's not related to the case studies that I just described. Yeah, we do have components that can work with online services.
Okay,
That's the intention of the question.
Okay, it's been asked. Could you said? Could you please share the referenced articles afterwards? If you've got any links, we can put them in the comments here, and it'll go straight onto the channels.
No problem.
And what do we have? We had Dick had one question: is health the main app sector for DL as opposed to ML? Should the principles focus beyond saving lives?
Yes. Simple answer, yes. We had one case where the goal of implementing AI was to save the lives, and that was about monitoring the production area so that people don't enter, dangerous zones. And then when the machinery operates and people are detected, or too many people are detected, then alert is triggered. But in most of the cases that we used to work with and that we're focused on, these are purely related to production, either automation or optimization. But yes, I totally agree with that. Yeah, okay. Health is a priority.
And on that, we're going to need to say goodbye. We are running 3 minutes over here. Thank you very much for your time today. Absolutely brilliant. And everybody watching as well as contributing and making the comments. It's what makes the show. Great sharing. Thank you very much. And
thank you very much.
If you want to know more or get in touch with Byte Lake, by all means, jump to their website and you'll be able to get in touch with the team. On that, Marcin, John, thank you very much. We will not be here in December. We are back in January.
Mid-January, slightly different part of the month. So
yeah,
check up on Meetup.
Good call, John. We are doing it rather than the first Tuesday of the month. We're going to do it in the middle of the month because I'm pretty sure we'll all be recovering from the lovely winter break. Yeah. And on that, thank you very much and see you next time and have a great Christmas.
Thank you very much.
Take care.